So last night, I was watching the Joe Rogan podcast on YouTube, and he was interviewing this Dr. Hotez. Did a fantastic job. It was episode 1451. I'll put a link to it in the description below. You should watch it. The good doctor was trying to dispel a lot of confusion and myths, and did a really wonderful job. In the video, he was talking about this reproductive number, this R0 value, and he was saying that the coronavirus has somewhere between an R value of 2 and 4, and we really need it to be less than 1. In the video, he did a really good job explaining what all that was, and so I want to explain some of the math to you in this video here. So let's listen to the good doctor speak for about 30 seconds and hope that's short enough of a time that this video doesn't get blocked because I'm borrowing Joe Rogan's material. But I'm doing it to try to educate people. So let's hear what the doctor had to say.
Why would that happen? Why would it come back? Why would it go away and then come back in the fall?
Well, there's a few things that are happening. One, all the social distancing potentially could interrupt the transmission. We use this number called the reproductive number, which describes the number of people that get infected if a single individual has it. So the number right now is between 2 and 4, depending on whose numbers you look at. The idea is you bring that below 1 by the social distancing.
So that's what we're going to talk about in this video. We're going to talk about what is the R value. It's sometimes called R0. Why do we need it to be less than 1? And how's this whole thing fitting together? So let's get to it, shall we? So the first thing you can do, if you wanted, you can go to your good old friend GOOGLE and you can look up what R0 means. And lots of great information. I thought that this website right here did a really fantastic job of just explaining that what R0 really meant is how quick a disease can grow in a population, especially considering a population that doesn't have any resistance. So how fast can it grow? Right now, the coronavirus is brand new, and so nobody has any resistance to it, so it just grows as quick as it can, right? So let's take a look at how this works, right? Let's say we have a person, and they've got the coronavirus, and they're carrying it, and they don't know. A value of R4 means that this person, our initial patient 0, would pass it on to 4 other people. And so over time, what would happen is we would start with one patient. That patient would spread the virus to 4 others, and each of those 4 people would pass it on to 4 of their own. So the first person would pass it on to 4 more, and 4 more, and 4 more, and 4 more. And then each of these people would pass it on to 4 more of their own. And pretty soon, you'd be overrun and overwhelmed with carriers of the disease. And so that's the real problem right there, is that if it has an R value of 4, it's going to grow extremely quickly. So let's look at a little chart right here of the value. So we start off with just one person, but one person spreads it to 4 more, which spreads it to 16 more. And all of a sudden, we started at 1, and now we've got a total of 21 cases. Boom, just like that. And then it's going to go up by 64, and then 256. And then it keeps up going up by a multiple of 4 every single time. It's going up by a multiple of 4 every single iteration. And that is absolutely uncontrolled, explosive growth. So if the R factor is as high as 4, that's absolutely going to be devastating. But what if it's on the low end? What if the R value isn't 4, but what if it's 2? What's that going to look like? So that would be, one person spreads it to 2, and each of these people spread it to 2 more. So instead of having this situation with an R value of 4, well, an R value of 2 would be we spread it to half as many people. So it looks something like this instead. How does this look? Well, instead of having 1 to 4, we have 1 to 2. And each of those 2 spread it, so we have 4. And so the growth would look much different. It would still be growing extremely fast, but not nearly as fast, because after 8 iterations, now these iterations, it's really hard to say exactly how many days come between 7 and 8. It could be as low as 2 days, it could be 4 days. We don't really know for sure yet. But either way, at the end of 8 iterations with a factor of 2, with an R0 value of 2, we have 128 cases instead of over 16,000. But still not even close to good enough. R value of 2 is still way too high. So let's go ahead and take a look at this. We're going to graph it but I want to show you what the equations are so that you can understand what where the graphs come from, shall we? So let's start with an R value of 4. The function we're going to use is 4 to the power of n minus 1. Now, I'm not going to get really into the science and math here. Not that I could even if I had to. I don't know nearly enough. I'm not 1 brown and 3 blue, which is a fantastic website. You should check it out if you haven't yet. He's got some great modeling of this. But I just want to give you a sense of what's happening right here. So let's do a t-chart, right? So n is the iteration of time, the number of days, or however you want to think about it. And this is our function. So we're going to plug in the value, the number of days, right here for n. So it's going to look like this, right? Now, 1 minus 1 is, of course, 0. Anything to the power of 0 is just 1, right? Plug in a 2. 2 minus 1 is 1. 4 to the power of 1 is 4. And we continue that all the way down, plugging in our exponents. So 3 minus 1 is 2. 4 squared is 16. And we end up with, this is the growth we would see for an R value of 4. If we had an R value of 2, this is what it would look like. Now let's go ahead and put these two functions on our graphs, right? So we're going to use our good old buddy Desmos right here. And let's take a look at what this graph would look like. So we start off, this is the number of cases is our y-axis, and this is our time, is our x-axis. So we're going to start off with a 4, an R value of 4. It goes up really quickly. An R value of 2, considerably slower. It takes more time before it absolutely just goes out of control. Do you see? But it still goes out of control fairly quickly. I mean, by the time we're right here at the 16th iteration, we are absolutely taking off. Whereas when it was an R value of 4, it was somewhere just after 8, and it just boom, exploded. But both of those are really, really bad. If you remember, the good doctor said that we want an R value less than 1. Perhaps that's wishful thinking. Perhaps social distancing isn't good enough. But what would it look like if we were close, like, say, an R value of 1.1, right? So let's go ahead and take a look at this. So using our good buddy Desmos, we're going to graph 1.1. It's in purple at the bottom right there. Do you see? It is growing, but it doesn't even look like it on this scale. It's barely going up. But then it does start to go up noticeably. And pretty soon, it starts to make that same exponential shape where it's all of a sudden totally out of control. It's not growing as fast as an R value of 4 or an R value of 2, but it's still growing really, really quickly. That slows it down, but it certainly doesn't stop it. It's still going to get out of control. So let's go ahead and take a look at that R value less than 1, like, say, 0.8. That's less than 1, right? Now, would you agree with me that 0.8 is the same as 4/5? And the reason we want to talk about 4/5 is we want to explore some of the math that's happening here so we can see why an R value less than 1 is what we're really, really hoping to get. So let's go ahead and use our function, our exponential function, 4/5 to the power of n minus 1. All right, so 4/5, when we square it, when we're on the second day, well, just so you make sure you remember how this works, 4/5 squared, the numerator and denominator are squared. It's 4 times 4 and 5 times 5. That's 16/25, right? And if we do the fourth day, we get 256 over 625. And then the eighth day, well, do you see that what's happening here is that the denominator is growing much faster than the numerator. And pretty soon, like here, they're rather close, especially 4/5, they're rather close. But here they're not. That denominator is growing so much faster, which means that these numbers are getting smaller and smaller and smaller over time. Because remember, n is a factor of time. It's an iteration of time. So if we do our t-chart for this, right, here's what it's going to look like. It gets smaller and smaller and smaller over time. And that's what we're hoping for. Whereas the other side, if it's completely unmitigated and nothing's happening, it just absolutely explodes. So we're hoping to see a graph that has a downward curve like this, of where we have an R value of less than 1. So now let's take a look at this graph. We're seeing versions of this all over the place. And let's take a look at it. So here's what's happening. At the very beginning, this is a very high R value. It starts very, it's slow, and all of a sudden just boom, explodes. And what ends up happening is, if nobody does anything, everybody either recovers or dies. And pretty soon, It's not that you have a population where nobody has any defenses, where everybody's susceptible. All of a sudden, people are immune to it because they've been exposed, they've recovered, their immune systems have adapted, and then it just starts to die off. Do you see? But it's going to explode. It's going to happen so quickly that it's going to overwhelm our healthcare system, and people won't get treated, and we're going to have a high casualty rate that we might not have, or definitely wouldn't have, if we can slow the spread. So if we can get that growth rate, that R naught value down close to 1, it's going to grow so much more slowly, and then it gives us time to treat people. There will probably be just as many people with this outcome as there would be with a high R value. It just happens over a longer period of time. And what ends up happening is we end up treating people, we get better treatments, maybe even somewhere down the line we get a vaccine. That's probably a long way down the line. But what ends up happening in both cases, we end up seeing an R value that's less than 1, and we end up having that gradual decline until it's completely under control. So anyway, I hope this video has been helpful. Give it a thumbs up, like it, share it. Anyway, I hope you guys are safe out there. Be calm, be rational, take care of each other, stay home.